yo, Metro Ninjas, and welcome to another exciting day in our geometry classroom. Today, we get the privilege of speaking about segment links that are formed by intersecting chords, secants, and tangents. So just a little refresher on our vocabulary terms. A chord is a segment inside of our circle with endpoints on the circle. A secant is a line or ray that passes through our circle, intersecting it twice. And a tangent is a line, segment, or ray that intersects our circle at exactly one point, and that point is called the point of tangency. So we have three different types of intersections that we're going to learn about. Okay? The first one is an intersection that occurs inside of our circle. So that is our type 1 intersection. If we have intersecting chords or secants, then the inside is going to be split proportionally. What's going to happen is we're going to take each individual piece, so A times B, set it equal to the other side, C times D. This is a proportional relationship because the inside of the circle has to be the same. So depending on what part the chord is running through, it's just taking up a different percentage of that circle. And this could be secant or chords. Why could this not be a tangent? Why would it not be a tangent? Anybody know? Tangent only touches it at one point, and it touches it where? On the outside. So this is an intersecting on the inside, so that's not going to work. So this can only be chords or secants. Most often you will see it as chords. Our second type of intersection, is a secant on the outside of our circle. Again, proportional relationship. Notice we are staying on the same line segment. We're not jumping line segments when we set up our ratios. Okay, so for this time, we're taking what's outside the circle. For the yellow line, it's A, and then multiplying it by the entire sum of the circle. So A times A plus B is equal to C, that's what's outside, times C plus D. If you have secants intercepting outside, that's what the rule is. And our final rule involves intersecting tangents. Okay? It could be intersecting another tangent. It could be intersecting a secant. Okay? But if it's a tangent that is intersecting, all we're going to do is square the tangent. So if it were to be two tangents that were intersecting, we would just square both sides. And then the secant follows the secant rule. What's outside B times the full length B plus C. Yes?
So would type 2 be inscribed?
Type 2 would not be inscribed. That would be an exterior angle. Remember, inscribed, the vertex occurs on the circle. Great question. Let's put our intersecting types into practice. Okay, so looking at number 1, they want us to solve for x. So remember, all we're going to do is we're going to stay along the same line. So this line is going to be a chord, and the other line is a chord. These are intersecting inside of our circle, so we're going to set them up as a proportion. So yellow line, 14 times 15. Green line, 10 times x. And then we're just going to run our math problems from there. So 14 times 15 is 210. And then divide both sides by 10. So x is 21. Nice and easy. Little layup to get the day started. Same thing going to number 2. We're going to stay on the line segment. We're not jumping segments. So 6 times 6 equals 4 times 5x minus 1. Now, in the past, students have been tempted to try to do that multiplication in their head as they're writing it in. Take the extra 10 seconds to write that problem out. Because what they do is they multiply the 4 and then forget that they also need to multiply and distribute that 4 into the 1. So 36 is 20x minus 4. Add 4 to both sides. So 40 is 20x. Divide both sides by 20. So x is 2. But for this problem, they didn't want us to just find x. They wanted us to find the length of BD. So we're going to take that 2 we found and substitute it into our equation. So we include the 4 because it's part of BD, and then 5 times 2 minus 1, which looks to be 13. Can anybody see what's going to happen eventually? Not yet. Our Algebra 1 skills are going to come back into play. Maybe on the next one. No, not on the next one. Solve for x. Take your time, draw out this step. I know you're tempted to not want to do it. But 24 times x plus 7 is 27 times x plus 5. Distribute. 24x plus 168 is 27x plus 135. We have a variable on both sides, so we move our variable first. We're going to subtract 24 from both sides. $168 is 3x plus 135. After we isolate our variable to one side, now we can subtract our constant, minus 135. Minus 135. So we get 33. Divide by 3, so x is 11. Any questions on that? That is an interior intersection. It is intersecting on the inside of the circle. All right, let's move to an exterior intersection. So number 5. Number 5 is an exterior intersection. We still want to make sure we're not hopping lines. We want to stay on the same line. But our rule for an exterior intersection is we take what's outside and multiply it by the whole length. So for our first one, what the number outside is 9. And then the whole length of our yellow line is 9 plus x. Same thing for our green line, outside 8, and then the whole line is 8 plus 19. If you want to go ahead and add those numbers together there, that's not a big deal. You're not really going to mess anything up. But if you're safe and making sure you're drawing everything out like you're supposed to, even less of a chance. So that binomial is being distributed into, so we get 9x plus 81 is 8 times 27. 8 times 27 is 216. Subtract 81 from both sides. 9x is 135. Divide by 9. X is 15. Any question on number 5? You want to talk about a little further? Well, let's start to tip the needle a little bit. Let's see if we can make this a little tougher on ourselves. We prefer it that way. Okay, so this is an exterior intersection. How do I know it's exterior? The intersection happens on the outside. Absolutely. Now we're starting to get into the fun problems. Exterior intersection for a secant is what's outside times the whole length of the line. So what's outside is 8, and then the whole line is 8 plus 3x plus 4. Same thing for the green. The outside is 7, and then the whole line is 7 plus 5x plus 2. So I'm going to go ahead and reduce inside those parentheses first, because remember PEMDAS tells us parentheses exponents multiplication. I'm going to go ahead and combine the numbers first, but you could do it that way. I think it might make it a little worse on you. So 8 times 3x plus 12 and 7 times 5x plus 9. So that looks a little bit more like what we're used to, right? They just threw some extra numbers at us to mess with us. So we're going to distribute our 8, distribute our 7. 24x plus 96. Make sure my times tables are still up to date. 35x plus 63. What's wrong, buddy? You okay? Variable on both sides, so we move our variable first. Bless you. 24x. 24x. 96 is 11x plus 63. Subtract 63 from both sides. 33 is 11x. And then divide by the coefficient. We know x is 3. Are we good on number 7? Number 9, again, we've got an exterior intersection, but this time it's involving a tangent. Okay. This guy up here is a tangent. How do we know? It touches our circle at exactly 1 point. The yellow line is still a secant. The yellow line is still going to follow what's outside 18 times the whole length x plus 18. But for our tangent, all we're going to do is square what they give us. They gave us 24. We're going to square 24. Does anybody see the awesome quadratics that is coming? $18 squared is 324. 24 squared is 576. We're still linear right now. But factoring's coming. 18x is 252. Dividing by 18, x is 14. So let's start off with an easy quadratic before we have to start factoring trinomials, foiling, and all that fun stuff. We've got a secant. We've got a tangent. How do we know the x line is a tangent? Good, it touches our circle at 1 point. So x squared is 27 because that's what's outside times the full length of the line, 27 plus 21. X squared is 27 times 48. And hopefully that's not going to leave us some weird number that we've got to factor down. But we get x squared is 1296. How do we undo a square? Square root. So we're going to take that number, put it right into our calculator, 1296 square root, and we're going to hit enter and hope we get a whole number. 36. Phew, that was a close one. Remember, in algebra, the real answer is what? Plus or minus 36. But in geometry, why don't we worry about the minus? Can't have a negative side length, correct? Yes. All right, y'all want another easy one, or y'all want to go ahead and jump into the pool? They said jump in. Here we go. So what type of intersection do we have, inside or outside? It's inside. So we're just taking our two pieces and multiplying them together. So for the left side, let's go x plus 6 times x minus 1. Oh boy, we get to FOIL. And then the right side, we have 12 times 10. Remember, when we have a binomial times a binomial, I know we're having Algebra 1 flashbacks, we have to FOIL. First numbers, outside numbers, inside numbers, last numbers. Okay. So x times x is x squared. X times negative 1 is negative x. X times 6 is positive x. And then 6 times negative 1 is minus 6. First numbers, outside numbers, inside numbers, and last numbers. So x squared plus 5x minus 6 is 120. Remember, if there is a quadratic, we have to factor. Quadratic formula is also available, but quadratic formula takes a long time. So we're going to go ahead and move the 120 to the other side. Because we need this guy to be equal to 0. So we end up with the trinomial x squared plus 5x minus 26 equals 0. So now we got to do our x box. We need two numbers that multiply to be negative 126, but when they add, it's 5. I don't really recognize two numbers off the top of my head, so this is where our calculator trick can come into play. We go y equals 126, or negative 126 divided by x. In your y equals screen, y equals, just do it under y1, negative 126 divided by x. It's second table. And what that does, it brings you up all the possible factors of negative 126. Remember, back in 7th grade, you had to make a factor table. 1, 126, 2, 63, 3, 42. Well, the calculator can do that for you. So what we're going to do is we're going to scroll until we find a combination that adds to be positive 5, negative 9, positive 14. And remember, we needed the 14 to be positive because our middle number was positive. So there's our factors, x minus 9, x plus 14. Now this brings us to our zero product property. If two numbers multiply to be 0, then separately they can also be 0. So x minus 9 is 0, x plus 14 is 0. So we get x is 9 and x is negative 14. One of these answers will not work though. Which one? Negative 14. Why? Can't have a negative side length. So that's what we call, anybody remember? Algebra 2 kiddos, you know what that's called. When it's an answer to the problem but not an answer to this problem. Extraneous solution. Extraneous solution. It's an answer, but it's not the answer for this guy. Are you ready to factor again? Oh yeah, we're going to factor again. This is good stuff to have on tape. Talk about sending out a highlight reel. Our ability to factor. This is where we go. You send this right to Harvard, they're like, oh man, that joker can factor. So x, it's what's outside. Outside x times x plus 5 equals outside 4 times 4 plus 2. Distribute our x. X squared plus 10x is 24. Is that what y'all got? 4 plus 2 is 6. 6 times 4 is 24. We've got a quadratic, which means it's got to be equal to what? 0. So we're going to subtract 24. If we're going to factor, it has to be equal to 0. Yes. Oh, I don't know. I did math wrong in my head. Good catch. I appreciate you. What's that?
Are we going to choose?
So we are going to cover completing the square next week. So you will have the ability to choose factoring, completing the square, or quadratic formula.
Oh, but, like on the test.
Nope.
there's no way
I'll let you, you can use whatever you want. You have to complete the square when you're writing the equation for your circle. And if it won't factor, you got to do the quadratic formula or complete the square. The quadratic formula will work for all three, but you may have to simplify a radical, which is where it gets squirrely. Because the quadratic formula is negative, b plus or minus the square root of b squared minus 4ac all over 2a. I know, she's excited. All right, so we need two numbers that multiply to be negative 24, add to be 5. Multiply to be negative 24, add to be 5. Again, if you don't recognize your factors, you can go y equals negative 24 divided by x and hit your table. That's really helpful with big numbers, but these little numbers, we should be able to see it. Okay, it's not 1 and 24, it's not 2 and 12. 8 and 3, absolutely. Positive 8, negative 3. X minus 3, x plus 8. Zero product property tells us that if two numbers multiply together to equal 0, then separately they can equal 0. So we're going to use that to split these jokers up. So we end up with x is 3 and x is negative 8. But only one of those answers works. Which one is it? X is 3. How come? Can't have a negative side length. I could. They're both right. All right. Let's do 16. Then I'll set you free. Yay. We have a secant. We have a tangent. Our tangent rule is we square the tangent. Where I see kiddos get in trouble is they square x, they square 5. They forget that x plus 5 squared is not just squaring x and squaring 5. And then 12 times 27. Where did I get 27 from? I added 12 and 15. Okay, so like I said, people want to go ahead and distribute this square and be done. That's not how math works. Remember, when you square something, it's like saying I'm multiplying it by itself twice. So x plus 5 squared is really x plus 5 times x plus 5. And then 12 times 27 is a big number, 324. Okay, go ahead and FOIL x times x times 5, 5 times x, and then 5 times 5. X squared plus 5x plus 5x plus 25 is 324. Since I have a quadratic, what do I got to do? It's got to be equal to 0, so I'm going to go ahead and move that 324 to the right side. So x squared plus 10x, I'm guessing 299. Minus 299 is 0. Okay, again, y equals negative 299 divided by x. And finding a 10. See if y'all can find your two factors. You should be practicing your calculator skills with me. Negative 299 divided by x, second graph. Positive 23, negative 13. So x plus 23, x minus 13. Since both of these multiply together to be 0, then we can say separately they are also equal to 0. So x is negative 23 and x is 13. Negative 23 is an extraneous solution because we cannot have a negative side length. So that finishes off our day. All right, go be great today.